Listen. So today's topic of discussion will be probability. Okay. So I hope you're able to see my screen. Listen. So we'll be discussing probability in that. So this is chapter number 13, guys. So that is okay. So here in your textbook in your 12th standard, they would have started with a topic called as conditional probability. Actually, this conditional probability is a connection of your last year's probability. So you need to recollect certain operations for you to solve them. Okay. So I just want to revise few topics before we get into what is conditional probability. Just before we start, what is first exercise. So I'm going to discuss the basics which you people already know. It's just brushing up few concepts. Okay. So you have been learning this probability chapter since your 10th standard, right? So you know what is probability. So if you ask you what is the basic definition, you're going to say it is a number of favorable outcomes to the total number of outcomes, right? So depending on what is the kind of event that is being performed, you will be able to take certain favorable outcomes. You know what is the total outcome, you will divide both, you will get a ratio, right? So before that, we need to see certain terms. So this probability mainly deals with the concept of experiments, right? So you do an experiment, you're more interested to know what is the probability of getting an output. So when you use probability, it is a technical term. If you ask me, probability is all about what is the percentage of your success or failure, right? See, for example, I'll give you a simple thing. Let's say you toss a coin. Okay. So I'm putting a question like this. What is probability of getting a hit? Everybody knows the answer. What is the answer? It is
1 by 2.
1 by 2. So 1 by 2 is actually a fraction, right? If I rephrase the question in a different way, okay. So what is the probability? It's like I'm asking you people. If I ask a layman, if I ask you, if they ask them, what is the percentage of their success? What will they say?
50%.
50%. How did they get it? It's the fractional part, the so-called probability multiplied with 100 is going to give you the percentage of success, and the remaining percentage is going to be the failure, since in this case you have 50-50 chances to happen, right? So that is how we need to start visualizing it. So what did we do? Tossing a coin is an event, right? So all these events firstly are called as experiments. So an operation which results in some well-defined outcome is called as an experiment. So when you perform an experiment, there are two kinds of experiments that we can actually perform. One is called as deterministic experiment, and the second is called as random experiment. So what is the difference between both, guys? So what do you mean by deterministic? Name itself is suggesting. Okay, so what do you mean by deterministic experiment? Means you know for sure a particular outcome. The best example I can say is, let's say I give you a ball, okay, you're holding it. If you leave your hand, that is the experiment, okay? It's a physics experiment. If you just remove your hand, you leave the ball, what is going to happen? For sure, it is going to fall down. You know all these facts, right? So this is an experiment. Is this a random experiment or a deterministic experiment? This is going to be deterministic, because you know what is the output, right? But in order to calculate the probability, so here you cannot, in deterministic experiment, there is no concept of asking what is the percentage of success or failure. It is going to be 100%, because you already know the success is going to be 100%, failure is 0. Whereas our interest of study in probability is about a random experiment. Means when you do something, we are interested to study what is the percentage of that particular event to have a success rate. Okay, so that is why our interest of study will be about random experiment. So a random experiment is the one whose outcome cannot be determined with certainty. You're not certain about what it is. It's called random experiment. In other words, if an experiment is performed many times under similar conditions, the outcome each time is not the same, then this experiment is called as the random experiment. For example, tossing a coin is a random experiment. Throwing a die is random. Drawing a card from a well-shuffled deck of 52 cards is a random experiment, right? So for all these random experiments, you have something called as favorable number of outcomes. Am I right? So that's what we had been learning. So if you are able to collect all those favorable outcomes and put them in the form of a set. Okay. 1 minute. So I'm repeating it. Listen, guys. So if you are able to take all those outcomes and put it in the form of a set, then that particular set is called as sample space. I'm sure you're thorough with this term also. So what is sample space? The set of all possible outcomes of a random experiment is called sample space for the experiment. It is generally denoted by the symbol S. So that is when a die is thrown, the outcome is 1, 2, 3, 4, 5, 6. So you put it in the form of roster form. You put it in a set in the roster form. We call it as the total number of outcomes that are possible, right? So when a coin is tossed, head, tail. When 2 coins are tossed, head 1, head 2, you know all these things. When 3 coins are tossed, how many outcomes are going to come, right? So all these things we will see. Next. Now comes the concept of event. So what is an event? So each element of the sample space, so you have written a sample space, that is you have written a set which contains all the possible outcomes. Each possible outcome present in the sample space is what is called as an event. Okay. Similarly, a discrete sample, see all these things, I'm just reading it out. Listen. So a sample space S is called discrete sample space if S is a finite set. Okay, you know what is an event? So event is what? Event is a subset of the sample space. So every element from the sample space is what is called as an event. Okay. So the problem solving trick is here we need to use a concept of sets. Right? When you use that, sample space is similar to the role of what universal set for all the problems related to a particular experiment. Null set is a subset of S and an impossible event. Right? So S is also a subset of S, which is called as a sure event or a certain event. You would have learned the concept of power set, right? So when you talk about a subset, how many subsets can you write for a given from a given set? If a set contains
The number of square.
it is 2 power n. See, for example, you have head, tail. Let's say this is the outcome. If I ask you to write the power set is a set of all subsets from all these sets. So one is going to be null set for sure. Second will be head. Second will be tail, and the last one will be head, tail. So you will have something like this. So this is going to be the power set of this, right? So indirectly, what they're saying is null set in the case of probability represents an impossible event. The sample space itself represents a certain event. Means every event in the sample space is going to occur, then it is 100% success. If none of them is going to occur, it's an impossible event. It's not going to happen. That is the meaning of not going to occur. In terms of sets, we call it as null set. So I hope I'm clear. Shall I proceed?
Yes, sir.
Okay. Now we will see the different types of events that are present. See, here is what you need to concentrate because there are 2 important events we are going to discuss. Okay. So one is a simple event. The other name for simple event is elementary event. An event is called a simple event if it is a singleton subset of the sample space. So what do you mean by singleton? Singleton means one output. So when a coin is tossed, then the sample space is head, tail. A is equal to head is the occurrence of head and B is equal to tail. The occurrence of tail are called as simple events. When 2 coins are tossed, then the sample space will be what? Head, head. It will be an ordered pair, right? Head, tail, head, and tail, tail, right? So if I take one of the events A is equal to head, tail, is the occurrence of head on the first and the tail on second is a simple event because it's a singleton. Singleton means 1. Okay, that's called a simple event. Next. So what is a mixed or a compound event? So a subset of the sample space S which contains more than one element is called as a mixed event, or when two or more events occur together, their joint occurrence is called as a compound event. For example, when a dice is thrown, then the sample space is 1, 2, 3, 4, 5, 6. Then event A 2, 4, 6 is the event of occurrence of all even numbers, and B 1, 2, 4 is the event of occurrence of an exponent of exponent of 2. We can say like that also. Yeah, exponent of 2. 2 power 0, 2 power 1, and 2 power 2 are compound events. Okay. So this is where the important concept starts, because I told you, right, your 12th standard starts with conditional probability. So for you to understand what is conditional probability, you first need to understand what do you mean by independent and dependent events. So that's going to be our next topic of discussion. So compound events are of two types. What are they? They are independent events and dependent events. So let's see what they are. Okay. So just give me a minute. So what do you mean by equally likely events? So outcomes are said to be equally likely when we have no reason to believe that one or more is likely to occur than the other. For example, when you see, I can put it in simple terms. When every event in the sample space has equal percentage of coming out, then we call that as a equally likely event. For example, when you roll an unbiased die, what do you mean by unbiased? All the 6 sides will be different numbers, right? When you roll an unbiased die, then the 6 faces will be 1, 2, 3, 4, 5, 6 are equally likely to come up. So what is the percentage of each event to occur? What is the probability of each event to occur? 1 by 6. So you can get 1 by 6 times. You can get 2 1 by 6. The percentage I'm saying 1 by 6. Like this, all the events have equal occurrence. So those are called as equally likely events. Similarly, if I say tossing a coin, so getting a head and getting a tail are equally likely events because they have probability of 1 by 2 and 1 by 2. Clear? Now comes the important term. So you have heard this word exhaustive events. So what do you mean by exhaustive events? So exhaustive means completely getting used. Okay, they are completely occurring. So a set of events is said to be exhaustive if one of them most necessarily happen every time the event is performed. Okay. So when a die is thrown, events 1, 2, 3, 4, 5, 6 they completely form a set of exhaustive events. Okay. That is the whole sample space. If every event from the sample space is occurring, then all those events put together are said to be exhaustive events. Okay. Now this one. The next is mutually exclusive events. So what do you mean by mutually exclusive? One minute, wait. I'll do one thing. I'll open your 11th standard textbook. Guys, are you able to understand or not?
Yes, sir.
So whatever I'm explaining is from your 11th standard, random experiments, outcome, sample space, all those things. Okay. In that, I'm talking about event, occurrence of an event, type of an event. So impossible and sure event, simple event, compound event. Okay. So we will discuss the algebra of event. Now, I explained what are exhaustive events. So if you see an exhaustive event, let us consider the experiment of throwing a die. We have the sample spaces 1, 2, 3, 4, 5, 6. So I'm defining the set of events like this. So events are generally represented by letters in uppercase. So A is an event where number less than 4 appears. So what will be the set A?
1, 2, 3.
1, 2, 3. Okay. B is a number greater than 2 but less than 5. So B set will have
3 and 4.
3 and 4.
4.
So C is a number greater than 4 that appears. So C is an event which contains
5 and 6.
5. Right. Now I'm asking you a question. Event A and event B put together, are they exhaustive events?
No, sir.
Why?
It is not equal to the sample space.
So what should be equal to the sample space? So what operation you're supposed to do between them?
Union.
Will you take the sorry, repeat it?
Union.
Yes, you do the union between them. Union means you combine both the sets and right. So if you combine event A and event B, what is missing actually?
5 and
3 and
6.
6.
5 and 6 are missing. So similarly, if I take B and C together, are they exhaustive events?
No, because 1 and 2 are missing.
1 and 2 are missing. So I'm taking I'm taking A and C together. Is it exhaustive?
No,
No.
because 4 is
Again,
missing.
4 is missing. But A, B, C all taken together. If I take A union B union C, then what will I get? I will get 1, 2, 3, 4, 5, and 6. So, which is nothing but the sample space. So, what we say is A, B, and C are put together are called as exhaustive events. So, such events A, B, C are called as exhaustive events. So, this word is very important. So, this is a mathematical operation between them. So, mathematically, what we say is the union between all the events that are appearing, if it is equal to the sample space mathematically, then it is called as exhaustive event. Right? I'm sure you would have learned last year. Next, we will speak about mutually exclusive events. So, what do you mean by that? So, you have an experiment of rolling a die. Sample spaces S is equal to 1, 2, 3, 4, 5, 6. So, consider events like this. Event A is an odd number appears, event B is an even number appears. Okay. Clearly, the event A excludes the B and vice versa. So, what do you mean by mutually exclusive?
There
Mutually
won't be
exclusive.
any intersection.
Yes. There won't be any common point between them. Right. So, event A is what? Event A is odd number 1, 3, 5. Event B is even number 2, 4, and 6. So, if I say A intersection B is null set, then we call these two events to be mutually exclusive events. Okay. And in terms of sets, they are called as disjoint sets. Right. So this is the definition. In general, two events A and B are said to be mutually exclusive events if the occurrence of one of them excludes the occurrence of other. That is, if they cannot occur simultaneously, in this case, set A and B are said to be disjoint and they are mutually exclusive events. See, for example, again, in an experiment of rolling a die, consider the event A an odd number and event B number less than 4. So what is going to happen? Event A 1, 3, 5, event B is 1, 2, 3. Something is common between them. So when I talk about both the events, A and B events are not mutually exclusive because the occurrence of 3 can happen in both the scenarios. Right? So I hope you're able to recollect these points. Right? So you know what is the probability of an event. So how do you define the probability of an event? So the axiomatic definition is like this. Please write it down. Can somebody tell me how do you define probability of an event? Don't say the number of favorable outcomes by total outcomes. That is a classical approach. Here we are trying to talk in terms of sets. Anybody? So probability of an event A is defined as the number of elements in the set A divided by the number of elements in the sample space. So the number of elements that are there in the sample space, or the set A, to the number of elements that are there in the sample space, is what we call it as probability of A. Right? So there is another event called as complement of an event or negation of an event. Right? So what do you mean by complement of an event? So what is the meaning of complementary of this? If A is occurring, then A dash, right, A bar will not occur. So these two events are said to be complement of each other, right? So probability of A plus probability of A complement is how much? It's going to be 1. Right? So the next point that we are going to see is, what do you mean by independent events or mutually independent events? Okay. So this is where the concept of conditional probability actually arises. So let's listen to this. So you have 2 or more events from an experiment. They are said to be independent if the occurrence or non-occurrence of any of them does not affect the probability of occurrence or non-occurrence of their events. Okay. So first write down the definition. 2 or more events are said to be independent if the occurrence or non-occurrence of any of them does not affect the probability of occurrence or non-occurrence of their events. Okay, let's see an example for it. So understand. Let a bag contain 3 red and 2 black balls. So 2 balls are drawn one by one with replacement. Okay. So 2 balls are drawn one by one with replacement. This is to be noted. So let A be the event of occurrence of red ball in the first row. So how many balls are drawn? 2 balls. So they are drawn subsequently. They are not drawn simultaneously. One is drawn and the second is drawn. But in the process, what are they doing? The first one drawn is replaced into it. Right? So if A is the event of occurrence of red ball in the first row, B is the event of occurrence of black ball in the second row, then what is the probability of occurrence of B? So if I ask you, what is the probability of A? What will you say?
3 by 5.
It is 3 by 5. What is the probability of B?
2 by 5.
2 by 4.
It is 2 by 5. Right? So this is when you do the experiment with replacement. Suppose I change the order and do it. Suppose I define A as an event of, suppose I do the second event first. That is, I draw black ball first. Then what is the probability of occurrence of black ball? I'll write
2 by
R.
5.
It is 2 by 5. So what is the probability of occurrence of red ball now?
3 by 5.
It is 3 by 5 provided
With replacement.
I do with replacement. Means whichever ball I've taken first, I'm dropping it back into the bag again and I'm doing the experiment. Then this is going to be the success rate. So if I write this property like this with replacement, then neither of the probabilities are getting affected. Means the probability of each of the event is independent, right? Whereas if I bring a scenario like this, first draw is a red ball, second draw is a black ball, I have to do this experiment without the replacement. Then what is the probability of red ball?
3 by 5.
3 by 5.
Now what is the probability of black ball?
2 by
1 by 2.
It is 2 by 4. Yeah, 1 by 2. So what has happened? Here the percentage of success was 0.4. Here it has increased. Right, here it was 0.4 guys, here it is 0.5. Means you have increased the percentage rate by 10%. By doing what? By decreasing the denominator. Right, mathematically decreasing the denominator, but in terms of experiment, you did without replacement. Means you created the dependency of the second event on the first. Now, can you say they are both are mutually independent?
No, sir.
Yes. So that is the point we need to understand for conditional property. Which event is done first and which is done later. That is the order needs to be followed. Okay. I hope this point is clear. Right. Now, what are dependent events? So, two or more events are said to be dependent if the occurrence or non-occurrence of any one of them affects the probability of occurrence or non-occurrence of other. Means the same example is taken. Let a bag contain 3 red balls and 2 black balls. The 2 balls are drawn one by one without replacement. Then what will happen? That's what we discussed now. Right. So so what will happen? A is the event of occurrence of red ball in the first draw. B is the event of occurrence of black ball in the second draw. So again, probability of A will be 3 by 5. Probability of B will be 2 by 4. So now they have become dependent events. Am I clear, guys?
Yes, sir.
Yes, sir.
Now see. One minute. Just a minute, guys. My device has got slow. I'll be back in a minute. Okay. I'm just logging off. So now you're able to see the screen, right? So we discussed till dependent events. Next is complementary events. This also I told you. If event E is occurring, then event E dash will the event which will not occur. So event E dash or E bar are called as the complementary of those events, such that the number of elements in E plus the number of elements in E dash is equal to the number of elements in the sample space. Next. So the next question is about occurrence of an event. So when you talk about a random experiment, let E be an event. Okay. So E is an event which has the sample, which has the set as ABC. If the outcome of the experiment is either A, B, or C, then we say that the event A has occurred. If it is nothing, if it is something outside that, then we have said that the event E has not occurred. Right. So probability of occurrence of an event, I have told you. So probability of E is equal to number of elements in the event E divided by the number of elements in the sample space. So all these basics you know. Okay. Now comes the algebra of events. This is important. This is also your last year's topic. Okay. Suppose I have 3 events A, B, C in hand. Then if I say, suppose the question says, what is the probability of A and B to occur? Then what is the mathematical operation we are supposed to use? So AND operation, if you see the keyword AND, the operation that we perform between A and B is intersection. Guys, are you able to understand? So A intersection B denotes the event of simultaneous occurrence of both the events A and B. If you say, what is the probability of event A or B to occur, then we use A union B. Okay. if suppose the question says the event A occurs but B does not occur, then there are two ways in which we can write. It is either A minus B or A should occur and B should not occur. And means intersection. So A intersection B complement. Okay. If there is a particular question saying the occurrence of neither A nor B, then A should not occur and B should not occur. And means intersection. So denotes the occurrence of at least, this keyword you will see, at least one events A, B or C. Then A should occur or B should occur or C should occur. So if the question says occurrence of all three events, then it should be A intersection, B intersection, C. Right? Next is. So if they say occurrence of exactly one of A and B. So what is the difference between the point E and point G? Can you guys tell me what is the difference? How will you understand it? So what is the difference between E and G?
In E, more than one event is also possible.
More than one event. Because they told at least one event should occur. Whereas here,
Only one single event is.
it should be exactly one event. So if you see the word exactly, then if A occurs, then B should not occur. Should not means and union, or if A doesn't occur, then B can occur. Okay, you need not memorize all these mathematical operations, just trying to put the conversions part. I hope you're able to understand this. So A is occurring, then B should not occur, or means union. A should not occur and B can occur. Okay. So the next is, if there is a particular experiment where the expectation is not more than 2 occurs. So not more than 2 means A and B can occur, or B and C can occur, or A and C can occur, but A, B and C should not occur. Right? So all these are set operations from Venn diagrams. Next, one and only one occurs. So if A occurs, so according to this, if A occurs, then B and C should not occur. Should not means intersection. Or if A doesn't occur, then B can occur, C also should not occur. Or if A and B do not occur, then C can occur. Any one should occur. That is the meaning. Denotes one and only one occurs out of all the three events that are possible. Denotes two and no more occurs. So A and B, only thing is you remove the complement. Right? A and B should occur, C should not occur. So you go in that way. So I hope you are able to understand this. So the third one is denotes at least two occur. There it was at least one occurs. Right here, point E was about at least one occurs. Here, at least two of A, B, C occur. So what should happen? A and B should occur, union. B and C should occur, union. A and C should occur. Okay. So all these things are from your 11th list. Okay. Now see. So the next is addition theorem of probability. So what do you mean by addition theorem? If A and B be any two events in the sample space, then the probability of occurrence of at least one of the events A or B, A and B is given by, listen. So probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Right? This is what is called as addition theorem of probability. My question is, how did you get this? How do we know that this is what has happened actually? So let's see. I have an event A. Okay. I have another event B. Right. Now comes the question. What is this green color portion completely?
A.
A minus A.
Now it's A, right? If I take this as A, this as B. Then if I say n of A is the number of elements in A, n of B will be the number of elements in B, then what will be the number of elements in A union B? It is the number of elements in A plus the number of elements in B. By doing this, what are we doing? We are actually adding something twice.
Intersection path.
So this number of elements of A union A intersection B is added twice, right? So we can write it as minus n of A intersection B, right? So what did I say the probability of a particular event is? Probability of an event is the number of elements in that event, right, divided by
Number
Sample
of
space.
N of S.
number of elements in sample space, n of S. So if I divide with n of S on both the sides, what is it going to happen? This event, I can call it as probability of A union B is equal to this one, I can call it as probability of A. This I can call it as probability of B minus this, I'll call it as probability of A intersection B. Guys, you're able to understand? So I just wanted to show this proof alone so that you'll understand how it has actually come. I hope you know this also. Next is, what is the probability of A union B union C then? Using the addition theorem of probability. It is probability of A plus probability of B plus probability of C minus, what are we supposed to remove?
Minus 5 is the intersection of the field.
So minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A. Is that all?
Minus probability of A intersection B intersection C.
It is not minus. It is plus. Why? Because in this process, you have removed it thrice already. You have already removed it, right? See, probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A. And you have to add back the part which you have removed thrice. You have to add it back once. Okay, that's what is probability of A intersection B intersection C. This you can revisit your Venn diagram concept and derive up like how I did it here. Okay, let's not waste much time on this. So this is all about the addition theorem of probability, right? So in the addition theorem of probability, you might have questions like this. If A and B are even such that they are mutually exclusive, then what is the mathematical operation between them? If events A and B are mutually exclusive, then A intersection B is phi. But phi according to probability is impossible event. So in this case, what will happen? Probability of A union B will be equal to probability of A plus probability of B minus how much? What is the probability of an impossible event?
0.
So when A and B are mutually exclusive events, probability of A union B can be written as probability of A plus probability of B. Okay, or else there will be a minus probability of A intersection B because they are not mutually exclusive. There is a dependence of each other. Okay. If A, B, and C are mutually exclusive events, then what would have happened? Probability of A union B union C would have only been probability of A plus probability of B plus probability of C. Am I clear, guys? Similarly, probability of A complement intersection B complement. Can you tell me what operation is this? Event A should not occur and B also should not occur. Right? So this one we can write it as 1 minus probability of A intersection B, the whole complement. I just want to recollect the De Morgan's law. So what does De Morgan's law state? A union B, the whole complement, is equal to A complement intersection B complement. Do you guys remember this? A union B, the whole complement, is equal to A complement intersection B complement. Similarly, A intersection B, the whole complement, is equal to A complement union B complement. Okay, these are called as De Morgan's laws. So what I'm going to do here is, so how can I write A intersection B? So can I write this as, listen, can I write this as probability of A union B, the whole complement? Guys, did you understand what I did according to the De Morgan's laws?
Yes, sir.
Yes, sir.
So this will be how much? 1 minus probability of A union B. That is removing the complementary. That is why here it is written like this. Okay. So anyways, I'll share the sheet after the class. You can go through all these things. So the remaining are also written based on the De Morgan's laws only. That part you can explore it. Okay. So this is the only one we are going to use in our CBSE. Remaining parts are used for higher end. Now comes your 12th standard. Okay. Now we are going to start your 12th standard. That is the first topic that is given in your textbook, which is called as conditional probability. They would have actually told multiplication theorem of probability if you open your textbook. So that multiplication theorem actually came from the conditional probability concept. Okay. So let's see what this conditional probability is. Guys, listen carefully. Okay. If there is any doubt, get it clarified. Let A and B be two events such that the event B is not a null set. Means it's not an impossible event. So the number of elements in B is not equal to 0, or probability of B is not equal to 0. Then if you write probability of A by B, something like this, or you write probability of A by B like this, then this is the expression which denotes the concept called as conditional probability of occurrence of event A when B has already occurred. So please write it down. So the different ways in which this is actually read is probability of A given B. That is what is given in textbook. Okay. So write it down. Probability of A by B. This is the meaning of conditional probability. Means you're trying to find the probability knowing the fact that B has already occurred. The formula part, everything, we'll see it later. First, understand the notation. So probability of A given B, or it is also called as probability of A considering B as the sample space. Okay. Probability of A considering B as the sample space. Please make a note of this. This point is not there in the textbook. I'll explain what is the meaning. Write it down. Probability of A considering B as the sample space. Okay. I hope you have written it. Right. So now I'm not going to teach any formula or anything which is given in the textbook. First, we are going to understand what exactly does this mean. When you write this kind of a symbol, how exactly are we supposed to find the probability? That's what we are going to see. Now see, this is an example. So there is a bag which contains 2 red balls and 3 black balls. One of them is drawn from the bag and the ball is not replaced. So first point to be noted here, conditional probability can be applied only when you have dependent events. Okay, we'll get into that slowly. So one ball is drawn from the bag and ball is not replaced in the bag. Then the second ball is drawn from the bag. Okay. So my interest of study is, so it is like this. They have defined the events like this. So the experiment is what? Drawing two balls from the bag. One ball should be drawn from the bag and it should not be replaced. Then the second ball should be drawn. That is the experiment. In which order that they have described it at the bottom. Let B be the occurrence of red ball in the first draw and A be the event of occurrence of black ball in the second draw. Okay. So I'm asking you a question like this. What is the probability of B? What is the probability of B, guys?
2 by 5.
So drawing a red ball, it is 2 by 5. So what is the probability of A?
3 by 4.
It is actually 3 by 5 only. Okay, when I explained you there, since you didn't know this concept, I didn't concentrate on an important point. There I explained it only for you to understand what is dependent and independent events. So here probability of A is 3 by 5 only, but probability of A known that B has already occurred is what is 3 by 4. Guys, you're able to understand. So event A is about drawing a black ball, but that black ball is drawn after which event? It is drawn after the event of drawing a black ball and not replacing it. So we are trying to find the probability of A, knowing that there is something like a black ball being drawn and it is not replaced, is what is 3 by 4. So this is what is called as conditional probability. Am I clear?
Sir, can you repeat it once more?
Which point?
The last point.
See, conditional probability is for dependent events. That is the point registered in your mind, right?
Yes, sir.
So what I'm trying to say is read the point carefully. Okay, A denotes what? The event of occurrence of black ball. In which draw? In the second draw. But we know one fact. What is it? It is not like the information is hidden from us. There is one information clearly given to us. In the first ball, there is only a red ball that is drawn and it is not replaced. So what is the probability of here? The only confusing point is B and A are swapped. Okay, so concentrate. A is the event of drawing a black ball. So probability of drawing a black ball known that the first event has already occurred is how much? Now, what is going to be the probability of A knowing that B has already occurred? When B has occurred, how many balls are present now?
4.
It is 4. So out of the 4 balls, you have a possibility of drawing 3 balls. Means your percentage of success has actually increased. Initially, how much was it? 3 by 5, 0.6. Now it is 0.75. So there it was 60% success. Now you have 75% success rate. And I mean, possibility of success, not success rate. 75% possibility of success. Am I clear? So we'll do some more examples and you'll understand. Don't get stuck to the same thing. We'll do some more examples. Try them. You'll understand. Next is, when a die is thrown, the sample space S is 1, 2, 3, 4, 5, 6. Okay. So when a die is thrown, generally they will not give sample space. So when a die is thrown, we know the sample space. So they are defining an event A like this. What is the event A? Occurrence of a number greater than 4. So what should be the elements present in A? So 5 and 6 should happen. And B is the occurrence of odd number. That is 1, 3, 5. Now what are they asking? So case 1 is, we need to find the probability of occurrence of A when B has already occurred. Okay. Now in this case, we need to find the probability of number greater than 4 when an odd number has already occurred. Okay. So what is odd number which is possible, which is greater than 3? 4. It is only 5. Only one number, right? So read the question carefully. So what are they trying to say? Find the probability of occurrence of event A. Let me erase all these things. Let me write it freshly. I hope you are making a note of it. Okay. So, what is the probability of, let's read the question, occurrence of A when B has already occurred? Now, in this case, we need to find the probability of a number greater than 4 when an odd number has already been occurred. So, what are they asking? What is the probability of A given B? What will be the answer? You're not sure, right? So, you're able to see the answer as 1 by 3. But how you are supposed to think is, see, most of us, what we do, we start thinking in terms of formula. First one was easy for us because we could count the number of balls that were there. So I told you there are two meanings of it. What is it? Probability of A given B, and I gave you another statement for it. The other way to think is
Considering B as the sample
considering
space.
B as the sample space means, how do you generally write this probability? The sample space will be in the denominator. In the case of conditional probability, the denominator, the one which has the event which has already occurred, should become like the sample space, and the numerator will have the intersection of these two. Okay, I will not think of this like a formula. Now see, we will first derive the value, then I will give you the formula. Think about it. So probability of A by considering B as the sample space. So when I consider B as the sample space, how many elements are there in B?
3.
3 elements are there. In those 3 elements, okay. So I'll read the point again. Probability of occurrence of A when B has already occurred. So the number of elements are 3. Then what are they asking? Event A is about a number greater, an odd number greater than 5. What are they asking? A is the occurrence number greater than 5. Yeah. So out of the 3 elements present, in the set B, how many odd numbers are there in set A? What is the intersection? What is the odd number which is common to both?
5.
5.
That is only one number, right? So the probability of A given B is 1 by 3. That is the meaning. You will slowly understand. Don't worry about it. So I'm putting it in simple terms. The other way of it is the number of elements in A and B put together divided by the number of elements in B. And if you rearrange this, okay, if you rearrange this, then listen. What I'm doing is I'm dividing the numerator and denominator with sample space, bigger sample space, n of B divided by n of S. So number of elements of A intersection B divided by n of S is what?
Probability of A intersection.
Probability of A intersection B.
Divided by number of elements in B divided by number of elements in sample space is probability of B. Okay. If you rearrange this equation, that is what is mathematically called as multiplication theorem of probability. Okay. For you to understand this better, let's do the second case also. So what is the second case? Probability of occurrence of B. So how to write? Probability of P of means bracket. Probability of whom? Occurrence of B when A has already occurred. Given A has already occurred. Did you understand how to write the statement? So P of B slash A is equal to, let's try to first find out the mathematical value of it. So again, here what should be taken as a sample space? Number of elements in A should be taken as a sample space. Okay. So what is the probability of occurrence of B? What is B? Probability of getting an odd number. So we need to find the probability of an odd number when a number greater than 4 has already occurred. Okay. So when a number greater than 4 has already occurred, and what is the condition? You need 2 conditions to be satisfied. It should be an odd number and a number greater than 4. So how many such are there? That is the number of elements in B and A, which is common. It is only one element, which is 5. Out of how many numbers that are there in the sample space A? Out of 5 and 6.
2.
That is why 1 by 2 came. That is why it is number of elements in B intersection A divided by the number of elements in A. Again, if I do all those mathematical manipulations, what will I get? I'll get probability of B intersection A divided by probability of A. Am I clear, guys?
Yes, sir.
This is under formula. This is what they call it as formula. Okay, this is what we are going to do in the exercise. Nothing else outside. If we will be just swapping, using them like formula, pushing the numbers here and there. That's it. But you need to understand the meaning of each term. Okay. Don't worry. As we keep doing problems, we will try to find the answers in a shorter way as well as using the formula also. So you guys give me confirmation. We are able to understand how to take this conditional probability, think, right? How you are supposed to think and all. You are clear, right?
Yes, sir.
Yes, sir.
Shall we do some problems?
Yes, sir.
So you can have your textbook. See the first question. So what are the two formulae that we have learned now? So-called formulae. Even if you forget, you should be in a position to recollect it. One minute. So what is the probability of A given B? It is the number of elements in, that is the probability of
A intersection B.
by probability of
B.
B,
B.
because B will be taken as the sample space. So probability of B given A is probability of B intersection A. It is the same as A intersection B by probability of A. So-called formula for conditional probability. Now let's solve the problems. See. So probability of A is 7 by 13. Probability of B is 9 by 13. We are not concerned about what events they are. Probability of A intersection is 4 by 13. Can you find out what is probability of A given B? So probability of A intersection B divided by probability of B. How much is it? 4 by 9. Right? Next. So let's do the next one. So a family has 2 children. What is the probability that both the children are boys given that at least one of them is a boy? So write down the sample space for everything. Write down the set for everything. So what will be the sample space, guys? So family has 2 children. There are only 2 possibilities. So what will be the sample space? Can you tell me?
BG, GG.
Boy, girl, boy.
Boy, boy, girl, boy,
Boy, girl.
Girl, girl.
Girl.
boy, girl, and girl, girl. Here, order is important because when you're writing the sample space, all the elements you're writing here are ordered pairs. So G comma B and B comma G do not represent the same, right? So what is the probability that both the children are boys, given that at least one of them is a boy? Okay. So how many events are we supposed to define here? Let's say the event A. Look at the way I'm writing, okay? Every problem has to be solved like this. So what is the probability that both the children are boys? So that will be event A. Both are boys. So what is given? At least one of them is boy. Correct? So they are asking what is the probability of A given B. So what is the formula for it? Probability of A intersection B divided by probability of B. What will we get? Right. So for that, we need to know the number of elements in event A. So I'm just giving a detailed analysis. What are the number of elements in event A? Both are boys. So this should contain ordered pair B comma B. B is what? at least one of them is boy. So it can be G comma B, B comma G, or
B comma B.
B
because
comma
they
B.
put at least. So 2 is also possible. If they said at most, then G comma B, B comma G should have come. So probability of A given B. So A intersection B is how much, guys? It is B comma B. So number of elements in A intersection B is 1 divided by the number of elements in B. Did you guys understand what I did? Okay.
Yes, sir.
So listen.
Sir.
I want to stress on, wait. I want to stress on one important point. I did it according to the formula I taught you. But what is the formula saying? You should not take the number of elements into. In your exam, what they expect is you have to write probability of A intersection B. So, what is the probability of A intersection B?
1 by
1 by
3 by 4.
no. Probability of A intersection B. A
1 by
intersection B.
4.
It is 1 by 4. See, all these things are expected in the exam. That's why I'm explaining. Okay. Correct? Number of elements in A intersection B is 1. Out of the number of elements in the sample space, the main sample space is 4. What is the probability of B? It is number of elements in B divided by number of elements in sample space. It will be 3 by 4. Correct? So here it will be 1 by 4, comma by 3 by 4. That will be 1 by 3. So this is what they actually expect in the exam, but you can find the answer to this in one step. So how can you actually find the answer? I told you a shortcut method. So both are boys. So probability of A given B means you will take B as a sample space. If you take B as a sample space, what is the event B saying? At least one of them. At least one of them means you are able to see 1, 2, and 3. So 3 is in the denominator. Numerator should be what? Both are boys. Both are boys. There is only one element. 1. Correct? Guys, am I clear?
Yes, sir.
Yes, sir.
Everyone?
Yes, sir.
Yeah. So what you can do is you can use this method to verify whether your answer is right or wrong. You actually find the answer, you can make them come. So this kind of detailed analysis is expected in the exam for marks. Suppose the question comes for 1 mark, you can directly write it. So yeah, you should know when to use it. Shall I move on to the next one?
Yes, sir.
Darshini wanted to ask something. Are you clear now?
Yes, sir. I'm clear, sir.
Next. So third example. You guys also try, along with me. 10 cards numbered 1 to 10 are placed in a box, mixed up thoroughly. And then one card is drawn randomly. It's a random experiment. Okay. If it is known that the number on the drawn card is more than 3, what is the probability that it is an even number? Okay. So first, what are the orders? What is the order of steps? First, sample space. 1, 2, 3 till 10. There are 10 elements in sample space. Then what is the expectation? One card is to be drawn. Okay. So our expectation is one card is to be drawn. If it is known that the number on the drawn card is more than 3, okay. So when they say known that means that is the one which will come in the denominator. That is given. Okay. It is known that the number on the card is more than 3. What is the probability of an even number? So again, I need to define 2. So A is probability of even number. So what will it be? The set will have 2, 4, 6, 8, and 10. Odd number greater than 3. What is it, guys? 5, 7, 9. That's
so
it,
they
right?
given only number.
Sir, all numbers more than 3, right? It is not given odd.
Oh, it is odd order. Oh, sorry, I read it as all numbers greater than 3.
Then it will be 4, 5, 6, 7, 8,
Yeah.
9, and 10.
4, 5, 6, 7, 8, 9, 10. So, okay, since though it is out of the question, can you guys tell me Had the question been like how I took odd numbers greater than 3, is there a possibility for you to find the probability?
No, sir.
Because there would have been no intersection at all. One is even, one is odd. Right? So now in this case, yes, it is possible. And one more important thing, when you're finding probability of A given B, you have to see that this is more number of elements. So what is the probability of A given B? It is probability of A intersection B divided by probability of B, correct? So
Yes,
this is
sir.
what we need to find. Now tell me, what is the probability of A intersection B? It is the number of elements in A intersection B divided by the number of elements in the sample space. What are the number of elements in A intersection?
5 by 10.
1 by 10.
What is that one? Number of elements in
4 by
A
10.
intersection B. What are all the
10.
intersection of? 4,
4, 6, 8, 10.
8, 10. It is 4 out of 10. So what is the probability of B? Probability of B is 4, 5, 6, 7, 8, 9, 10. That is 7 out of 10. That is the number of elements in B divided by the number of elements in sample space. That is 7 by 10. Right? So take both the values and substitute. What will be the answer? 4 by 7.
4 by 7.
That's it. Right? So how will you directly
Yes,
write
sir.
it, guys? Probability of A given B. What should be in the denominator? The number of elements in
B.
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 Number of elements in B are 7. Okay. Then numerator should be the common elements of A and B. What are the common elements of A and B? 4, 6, 8, and 10. There are 4 terms, so 4 out of 7. So we'll get the answer in one step. Correct? Next. So can you guys try this? Example 4. In a school, there are 1,000 students, out of which 430 are girls. It is known that out of 430, 10% of the girls studying in class 10% of the girls are studying in class 12. What is the probability that a student chosen randomly studies in class 12, given that the chosen student is girl? Sample space. So number of elements in sample space is 1,000, out of which 430 are girls. So what are they asking? What is the probability? Okay, probability. What? So you can always do a rough work. What is the probability that a student chosen at random? So for everything, it's like A given B only. You have to define what is A and B. So probability that a student chosen randomly studies in class 12, given that the chosen student is a girl. So how do you define event A? Student chosen studies in 12th. What is event B?
The student is a girl.
That's it. Okay. Now tell me what are the number of elements in A? Student chosen studies in class 12. There are 1,000 students, out of which 43. So is it a girls' school? No, right? So in a school, there are 1,000 students, out of which 430 are girls. So obviously 7, how much is it? 670, yeah? 570.
570.
Yeah, 570 are going to be boys. Okay, it is known that out of 430, 10% of the girls study in class 12. So student is a girl. So student chosen studies in class 12. So in class 12, how many students are there? That's what we need to understand. Oh, we don't need A, right? Why am I even trying to find it? Because what is the probability of A given B? It is probability of A intersection B by probability of B. So number of Now, probability of B is how much? What is the probability of? Sorry, 430 is the total number of girls. Student is a girl. Oh, correct. Yeah. 430 by
1000.
1000.
So probability of A intersection B, that is a student should be in class 12 and the student should be a girl. What is it? 10%. So 43 divided by 1000. Correct? So what is the probability of A given B? That is 43 out of 1000 divided by 430 out of 1000. So this and this will get cancelled. So it is 1 by 10. So it is 10% chance that this kind of a selection can happen. Okay, how will we write it in one step? Probability of A given B. Sample, the denominator will be student is a girl. How many girls are there? 430 girls are there. Numerator should be student chosen in study. So it should be a girl and studying in class 12. So 10% of 430 study in class 12. So it should be 43. So 1 by 10. Okay, moving on to the next one. Next, example 5. A die is thrown 3 times. Okay, so die thrown 3 times is the same as throwing 3 dice at the same time. So die is thrown 3 times. Events A and B are defined as below. So event A is 4 on the third throw. Event B is 6 on the first and 5 on the second throw. Find the probability of A given that B has already occurred. Okay. So sample space contains how many elements?
8, sir.
No. 8 is for the coin.
36.
6.
216, ra. 6 cube.
Oh.
Okay, sir.
It contains 216 outcomes. See, I'll show you what are they. For example, triplets, 111, 112, 113. You keep writing like this, no? You will have 216 outputs. It will be in the cube formula. So 216 outputs actually come out. Out of which, what is event A? 4 should occur on third throw. So the triplets are there, no? So in the triplet, in the third throw, what should happen? There should always be a 4. So how do you write the set for A? Observe 1 comma, it should start 1 1 4. I will change the second number 1 2 4. I'll change the third number. So it keeps going like this. It will go till 164. Correct? Then here 214, 224, 234. It keeps on going like this, right? So like this, you can write till what number?
36. 664.
So you guys are able to understand. See, I'll show you the difference. Concentrate. So 1, I'm fixing the first number and the last number. 114, 124, 134, so on. Uh, 164. Let me write it down. Then you will have 214, 224, 234. Yes, 264. The last one will be 664. That's right. So how many such elements are there? 1, 2, 3, 4, 5, 6. 6 into 6, you will have 36, right?
Yes, sir.
Yes, sir.
So B is how much? 6 on the first throw and 5 on the second throw. So they are asking probability of A given B. So we don't need probability of A at all. Because what is the formula saying? A intersection B divided by probability of B. So B will be how many? 6 on the first throw. So 6 should be fixed and 5 should be fixed. So 1, 6, 5, 2, 6, 5, 3 keeps on going till 6, 5, 6. So how many outcomes are there? So probability
6.
of B, it is 6 out of 216. What is the probability of A intersection B? That's what we need to understand. So A intersection B will be in such a way, there is only one event that is going to intersect between these two. What is it?
654.
654.
Very good. So it is 654, which is common in both. Right? That triplet is common. So 1 out of 216. Answer will be, so probability of A given B is 1 by 6. Yeah, we have to write A. I was just thinking, why did we even write A? But we have to write it. So I hope you know the shortcut, right? So we'll do one last problem. With that, we'll end the session. So die is thrown twice. So twice means sample space.
36.
6 outcomes.
6 power n is equal to 2. So it will have 36 outputs. And the sum of the numbers appearing is observed to be 6. What is the conditional probability that the number 4 has appeared at least once? So what is the probability of A given B? Here A is what? A is 4 has appeared at least once. B is what?
Sum is 6.
Yes. Sum of numbers 6. So probability of A given B is probability of A intersection B by probability of B. So we'll find out what is the probability of B. So what is the sum of numbers that gives us 6? 1, 5. Ordered pairs are what? 2, 4, 3, 3, 4, 2, 5, 1. That's it. So what is the probability of B, guys? 1, 2, 3, 4,
5
5.
by 36.
5 by
Yes.
36.
What is the probability of A intersection B? So what if 4 has appeared at least once? So 4 has appeared at least once means here and here 4 has appeared. So probability of A intersection B is 2 out of
36. 5.
that's what they're asked, no? 4 has appeared at least once.
Sir, can we take 4, 4, sir?
4, 4 is not going to give you sum as 6, no? That sum of 6 has to be satisfied. That's why it is A intersection. 1 minute. What is the conditional probability the number 4 has appeared at least one? Given what? Given that the sum of 6. Yeah, what we have done is right. So what is the probability of A given B? It is 2 out of 5. Guys, I hope I'm clear. I'm taking the intersection of this event and 4 appearing at least once.
Sir, we are taking the conditional probability as A, sir.
See, the thing is, when you're reading the question, listen to it carefully. When they ask the question, what is this is the first question they have asked conditional probability. In all other questions, they would have said probability only. So, what is the conditional probability that number 4 has appeared now? This is the way you need to take probability of always, even before you start writing all the story, probability of capital P of means bracket. Okay. The only formula that I'm using is A given B. I'm not confusing by using B given A and all those things. For every problem in this exercise, I'm using only A given B, where A will be the one for which we need to find the probability. Now, what is the conditional probability that the number 4 has appeared? So A will be the event where the number 4 has appeared. Whatever is coming after that probability, right? that will be the event A. What is coming after the word given or known, that will be B.
Okay.
Okay. At least once. I've written it here already. Okay. So that is how you take the data. It is not like I'm in this question, I'm taking this as A and that as B. Nothing like that. Whatever comes after the word probability will be A. Whatever comes after the word given or known will be event B. Okay. So the remaining problems you can try. If there is any doubt, you can let me know in the next class. Okay. Next class we'll complete this exercise. Actually, you can do the next exercise also, which is called as multiplication theorem of probability, the same thing. Okay. So first two exercises concepts are over. Third one is Bayes theorem. Maximum by next class maximum by this week we'll complete it. Okay. Don't log up, just wait.